So today we're going to talk about derivatives. We have an example here, but before we start this example, let's look at how derivatives work. If we have an equation in terms of y of x, that is y equal to x to the power of n, if we take the derivative of this equation, the n comes down, and then it's n minus 1 is the new power. So if we do this with numbers, if we have x squared, the derivative of this would be, we bring the 2 down, we have our x, and then we minus the original power by 1. So this is equal to 2x to the power of just 1, which we don't have to write because it's implied that it's there. So when taking the derivative of this example, we notice that we have 2 independent variables. These are our independent variables right here. So you have a function of y of t, y being the dependent variable, and t being the independent variable. So we have 2 independent variables, right? And they're being multiplied by one another. Maybe not directly, but they're being multiplied in the middle. So whenever you take the derivative of 2 independent variables that are being multiplied, we use the product rule. And the product rule states that we have a function. The function is, let's call it y equals f of x times g of x. We're taking the derivative of y. So derivative of the first part of the function times the second part of the function, unchanged, plus the first part of the function, unchanged, times the second part of the function in derivative form. So this is important because for us, our f of x is going to be our t to the power of b, and our g of x is going to be our e to the power of 3 over t. Okay? So when we take the derivative of this function, we're going to follow this roadmap here. So derivative of y, we take the derivative of f of x first, which is our t to the power of b. So we bring the b down, and then the new power of t is going to be b minus 1, okay, times our g of x, unchanged, right, plus our f of x, unchanged, times the derivative of g of x. So for the derivative of an exponential, we have e to whatever that power is. So y is equal to e, whatever the power is. If we take the derivative of this, is going to be e to whatever the power times the derivative of that power. So let's go ahead and apply that here. We can do it on the side. Derivative of only e to 3 over t is going to be e to 3 over t, and then the derivative of that. So let's look at this fraction only. In order to make it easier on ourselves to take the derivative of this, we can rewrite it as 3t to the power of negative 1. Right, so if we take the derivative of this, we know we have to bring the power of negative 1 down, and it multiplies by 3, so negative 3t minus 1, and then minus another 1. So this ends up being negative 3 e to the power of 3 over t times t to the power of negative 2. Now we can write this here. Okay. And now the last thing to do is just combine everything. So let's go ahead and do that. We can write this as b tb minus 1 e 3 over t minus 3 e to the 3 over t. And notice we have tb and t to the negative 2. We can multiply those and combine the powers, so we'll end up with tb minus 2. And this is the reduced answer for this derivative.